Right, okay, let's look at this question. This is a question under the Poisson distribution. So, a motor car repair workshop tows in an average of 5 damaged cars per week. Okay, this is a Poisson distribution because they have said that assuming that the number of damaged cars towed per week follow a Poisson distribution. So they have said that it's follow a Poisson distribution means that it's a mean, right? It's a mean. So it means that it's not exactly 5 damaged cars per week. So it means that it's average. Average. They talk about average. In 1 week, there is 5 damage, right? They tows average of 5 damaged cars per week. Alright, it's a mean. It's not telling you that every week there must be 5 damaged cars. No, there must be. No. It's just telling you the average, right? According to their study, is 5 cars in a week that need the service of from this workshop. So which is 5 damaged cars per week. So this is the mean. So remember that. So, okay. And the question asking to find the probability that more than 4 cars are towed in the particular week, right? More than. So it means that more than 4 cars are towed in a particular week, in 1 week, right? Means that in 1 week. So we know that if you want to using Poisson distribution, this is the Poisson distribution which you need to define the mean, right? The Poisson means in a particular week means in 1 week the mean is 5 cars. All right. So now they said more than 4 cars are towed. So more than 4 cars are towed. So I have already teach you how to using statistical table. Okay, very simple. So you have to write this in the form of greater or equal, right? The format. So greater or equal 5, right? As more than 4. What is mean by more than 4? It can be 5 cars, 6 cars, 7, more than 4, right? More than 4 means must be start from 5 cars, maybe 5 cars, 5 damaged cars, 6 damaged cars, 7 damaged cars, and so on, right? So means start from 5 and above. So that's why we have at least 5, right? So we can using the statistical table under Poisson probability, right? Poisson probability. So with the mean of 5, right? In 1 week, the mean is 5. So we find there is a 5 here. Can you see that? 5. So we find the value of 5 greater or equal 5. So we search for 5 here. 5 0.5595, right? According to the value here, 5, it will be 0.5595. The mean is 5. The value of greater or equal 5. So 5595. So the answer for question A would be 0.5595. As simple as that. Alright, okay. How to using the Poisson distribution in solving this problem? At most, 10 cars are towed in 2 weeks. So in 2 weeks, definitely the mean will also change, right? For 1 week, the mean is 5. So definitely for 2 weeks, so the mean will be 1 become 2 weeks, so you double. So this the mean also will be double, 5 times 2, which is 10, right? For question B, the mean now for 2 weeks is 10 cars, right? We expected, okay, it's not the real one, but we expected that if 1 week is 5 car damage, so means 2 weeks we will expect to have 10 car. All right, this is the way we're using Poisson distribution. So and the question asking us to find at most 10 cars, right? At most 10 cars. So at most 10 cars is actually less or equal 10, right? Paling banyak 10 kereta. It can be no car, right? No car damage in that 2 weeks. All right. Then the workshop will scared lah. Okay. 1, 2, 3, 4, 5. What is mean by less? At most 10. Mean at most lah. Okay. In that 2 weeks, at most also 10 cars will be damaged. Okay. That need the service. So means that it can be 11, can be 12, can be 13, can be 14 car, can be 15 cars, so on and so forth, right? But they want at most 10. What does it mean by at most 10? Means 1 up to 10, right? But there are so many possibility. It can be 11 cars, can be 12 cars, can be in that 2 weeks you have 12 cars that damage, that need the service, right? So never mind. So because we know that the total probability, yes, this is a discrete, I need to take everything 1 minus away. 11 and above, right? I need to minus away everything here, right? I have to minus away everything here. Means that I just want from at most 10 means what? From 0 up to 10, right? So I need to take everything minus away at least 11. I don't want 11 and above, alright? 11 and above, I don't want. I just want at most 10, alright? So then I can read from statistical table the value of, as long as you have x greater or equal, that's why I convert it become this form. So you read the mean 10 and the value 11, right? So let's look at the statistical table under Poisson probability. So you look at the mean here, alright? It will be 10, right? The mean is 10, so it's here. So the mean is 10, lambda is 10. So and the value of greater equal 11. So you find for 11. Where is the value of 11? Okay, this is 9, so we go for the next page. Right? So 10, 11, can you see that? 0.417, 0.417. So for this, it will be 0.417. So if you minus, you are getting the answer of 0.583, right? 0.583. Okay, so very simple. So what I want to tell you is, this is for 1 week that you have 5 cars. So for Poisson distribution, if let's say the week is double, right? It's become 2 weeks. So definitely the mean also will be double. So become 10 cars, alright? So this is what I'm going to tell you. Alright, lastly, the question is saying that between 15 and 20, between 15 and 20 cars. So we know that it's between 15, between 15 and 20 cars. But okay, I'm going to tell you in this question that if the question is telling you that between 15 and 20 inclusively, cars, inclusively means that you should put an equal here. 15 less or equal x, less or equal 20. If they say inclusively, if the keywords here, but this question is clearly stated that it's between 15 and 20 cars are told in 1 month period. Oh, now it's 1 month, right? As you know that 1 month, you have at most you have 4 weeks, right? You have 4 weeks, so we understood that, we know that it's at 4 weeks. So we have to change the mean before we calculation. That's a very important thing here. So we have to be very, read the question carefully, as this is now we are studying about the Poisson distribution. For this case is in 1 month. Right, and for 1 week, per week they have 5 damaged car, right? So 1 week we have 5 damaged car, right? 5 damaged car. So if 1 month, okay, we have 4 weeks. So definitely this is 4 times. So this one will be 4 times also, 5 times 4, which you have 20. Means now the mean is already 20. It's no longer, it's changed according to the number of weeks here. So basically, very important, okay? The time interval very important. So if 15, 20, right? In between 15 and 20. So I'm going to list out for you what's the meaning of between 15 and 20, right? What is meant by between 15 and 20? It means that 16 cars, can be 16 damaged car, can be 17, can be 18, can be 19, right? But cannot be 15, right? Between, there are no equal, can be 16, 17, 18, 19, and 20. 19, oh sorry, it's just 16, 17, 18, and 19. This 4 number here. So means that 20, 21, 22, 23, and above we don't want. We just want 16 up to 19 because it's between 15 and 20, right? So 16 up to 19. So means that 20 and above we don't want. So we start from 16, right? Because this is above, right? Above. So it start from 16, px greater of equal 16. Greater or equal 16 means 16, the probability is 16 and above. Minus away probability is 20 and above. Why? Why I do this? Because I just want 16, 17, 18 and 19. 20 and above I don't want. That's why I have to minus away at least 20, right? I have to minus away at least 20. So now, again, I have already converted it into the form of greater or equal by using some simple logic. So, okay, from here, with this mean, I can read the values from the statistical table. So let's go for the statistical table and find for the value. Okay, 20, the mean is 20. So, okay, let's look at here. You have mean 20, right? So it's starting from here, mean 20, they have long list here, right? So you have 16 and 20. 16 and 20. For the mean, lambda is 20, and the value here is 16, right? 16 is 0.8435, right? 16 is 0.8435. 0.8435 minus away greater or equal 20. So look at here, lambda is 20, greater or equal 20. So this is the value 20. 5297. 0.5297. So after you subtract, so you have the value of 0.3138. 0.3138. Alright, okay, I just solved for you, and so that you can see how I'm solving the question involving probability in Poisson distribution. Probability involving Poisson distribution. Alright, that's all for this question.